gonna share my screen. All right, so today we're going to be learning about cookies and sessions. This doesn't actually have too much to do with Django in particular, but I'm going to show you these concepts through the context of a Django application. So I have just scaffolded up a quick Django application before the start of this demo. I'm just calling it simple auth because we're going to demonstrate some simple authentication methods today. URLs is pretty simple. It has one app called blog. Blog currently just has a home page at the root route, renders the index. So in our templates, here's our index. It's just a simple H1, says welcome to my blog. And when I go to my browser, looks like the server is running, and here's what I can see so far. So that's what we're starting with. All right, so up until this point, we haven't really had the ability to log in or out of our application. Now we've been saving data in our database, but we haven't been able to securely and reliably associate that data with its owner. So most modern web applications require users to log in and start a session so they can modify only their own data. Today, we'll be learning about some related concepts and technologies that are used for logging into a web application, such as cookies, sessions, and password hashing. Later this week, well, tomorrow, we'll be learning about some of the tools that Django provides that make it easier for us to implement authentication in our applications. So to kind of repeat that in a different way, today we're going to be creating our own authentication system by hand. Now, I just want to caution you that, like, in the working world, this kind of thing is commonly referred to as a very bad idea. You're not supposed to write your own authentication workflow. You should just use tools that, you know, implement this in a secure and reliable way so you don't miss any edge cases. But just for our learning purposes, we're going to do this once today, and then you're going to have a homework assignment that challenges you to do similar things. And then after that, we're going to be using the tools that Django provides that let us do these same things in a more reliable way. But since the Django tools are all very automatic, I wanted you to actually understand what's going on. So we're going to be doing it by hand at least once. And of course, I expect there's a lot of new concepts today. So please feel free to ask questions at any point. So the first thing we got to learn about specifically are cookies. Has anyone heard of cookies before? I expect you have with the whole like European privacy policy thing. But can anyone tell me what a cookie is? I can't hear you. You're a little quiet.
So it tracks like what pages you've been to?
It does effectively track the pages you've been to. Yeah.
Like a super small form of like session storage or something like that. When I was reading about it, it was compared to that.
Kind
It's
of.
a little string that you can receive if you go to a website.
And it's stored on your computer, the client's computer.
Okay. There was a couple of voices at once. Could we repeat that? It's a little string stored on the client's computer or what?
Yeah, it's a string. Well, cookies are strings that you're given if you visit another website or server. And it's just store information that they can correlate on their end. I don't know if you like log in or, well, really anything.
Yeah. So a cookie is a small piece of data. It's a small string that a server basically leaves on the client computer, and then the client will send it back up later. So cookie is small string of data So the client will set this small string of data when the server tells it to. And this is done using a specific header called setCookie. So I want to clarify one thing real quick. There are actually, let's say, two different definitions of cookie that you might hear. What we're going to be talking about today is just what I've written here in front of us. It's a small string of data stored in user's browser when instructed by the setCookie header. So you might also hear the word cookies to refer generally to any web technology that can be used to track people, similarly to the setCookie header. So in some contexts, you'll hear it used kind of vaguely, imprecisely. So I just want you to be aware of that. But today we're going to be using the more kind of technical definition that it's the data that is set by this specific header. This is a browser cookie. So the basic way that cookies work, they get transmitted back and forth, is first the server sets the cookie using this setCookie header. And then in the future, whenever the client sends another HTTP request to that same server, it automatically sends all of its cookies back that were set from that server. So not all the cookies that have ever been set from every website you've ever been to, but just the cookies that that website set will be sent back to them. All right. So now the cookie headers themselves have a little bit of syntax to them. It's more than just a simple string. But fortunately, Django has some tools that'll help us read and write these cookies. So we can just work with dictionaries on our end and not really have to think about the actual syntax of the cookie string. But it'll be easy enough to read when we see it raw just in the browser. Okay, so let's actually send some cookies around so we can see what this looks like. So I'm going to make a new route here. Set cookies. It's going to do what it says it does. So this route is going to actually render the same page. I'm not feeling very creative here, so it's going to take you to the same place. But we're going to perform some extra logic before the page renders. So notice I'm not just returning the response immediately. I'm assigning it to a variable so I can access some properties on it. We're going to call response dot set cookie. Just for our very first cookie. Cookie key is foo. The cookie value is bar. So let's just see what that looks like. We'll return the response. Actually, I'm going to open this in an incognito window. So this is going to be like a fresh start. It's not going to use any cookies I had previously. Okay, so here's the home page. It says, welcome to my blog. If we look in the network tab, and we inspect the request, I'm going to look at cookies, looking for cookies, and I don't see anything about cookies here. In the request headers, there's no cookies. In the response header, there's no set cookies. So currently, this home page of my blog doesn't do anything with cookies. So now we're going to go to this set cookies page, which I have to add this to my URLs. Okay, so now I've got this set cookies route set up. So let's go visit that in my browser. Okay, so it's the same page, welcome to my blog, but
I think it might be because of the hyphen versus underscore thing, because you have an underscore in one spot in the code.
well, the URL is with the dash, and the view name is with an underscore. I mean, this is definitely a different URL, hang on.
I think you're missing an S on response.set cookie.
No, it's supposed to be singular. Oh my gosh, okay. So I had words typed into the filter here on the side. So I don't know, I must have just like accidentally hit my keyboard or something and there was an L in there. So it was only showing me requests that start with L, which there were none. Okay, so I cleared the filter out. Now it's showing me the set cookie. It's showing me the response request I was looking for. Sorry, I was just getting confused about the UI here with DevTools. So anyway, what I was trying to show you is when I send this request for set cookies, here I can see in the network tab, this is the request that I sent. So here in the response headers, we've got set cookie coming from the server. This I was telling you about before. Foo equals bar. This is that key value pair that I set. And then this was set automatically by Django, path equals slash, just saying that this cookie is valid on the entire website. Anywhere inside of localhost 8000, it'll send these cookies back. And because I've refreshed the page a few times at this point, you can see on the request cookie foo equals bar. So I'm actually going to start a new incognito session, try to show that again. So the first time I go to set cookies, in the request, there's no cookie header. The first time I'm visiting this page, my browser doesn't know anything about the cookies, so it's not sending anything up to the server. But the server is configured on every response to try to set this cookie foo equals bar. So in the first response we get from the server, so we see the set cookie foo equals bar. Now, if I refresh the page, since we've already had the cookie set, now when I look at the request again, response server is still setting it on every header, on every response. But now in the request, we can see that the client is sending up that cookie foo equals bar. So that's the most basic way that cookies work. Even if I go back to the home page now, just localhost 8000, look at the headers here. So now the server is no longer telling me to set any cookies because the home page didn't have that header set. It was just the set cookies page. But if I look in the request headers, my browser is still sending this cookie back because I'm still in the same domain. So any requests where I stay in the same domain and the same website, it's going to keep sending these cookies back automatically. So this is really handy because we don't have to write any client-side code to manage our cookies. This is just built into the browser automatically. We just have to understand what the default behavior is so that we can leverage it in our applications and understand when it's working correctly. All right, so cookies also have some options that you can set for them. So a really important feature for cookies is expiration. You don't want the user's browser to store your cookie forever, depending on what type of data you're storing. Some information, your user might want to store it indefinitely. Some information doesn't make sense after they've closed their browser. They want to forget about it at that point. Some information, you only want to save it for 10 or 20 minutes. Like imagine a login session at your bank. You don't want to save that indefinitely. You want to make sure that the user is actively using your website in order to maintain their active session. So in order to manage that, there's a property called max age, which is just the longest amount of time that this cookie can be valid for. So this is measured in seconds. I'm going to set it to 5 here. Then we're going to go back to the set cookies page. So I just refreshed the page twice in a row really quickly. And so now you can see from the server, there's 2 set cookie headers. We still have foo equals bar. And then we've also added temporary key is temporary value. And it's got this expiration date. So I only set the max age, but I think either Django or the browser is automatically setting an expiration date based on the max age. I believe you only have to set one of these, and then the framework you're using will set the other one automatically to match. So yeah, this is saying that the cookie expires 5 seconds in the future from when it was set. Now you see it in the request header. My browser is sending this temporary key with a temporary value. This temporary cookie is being sent up because I refreshed the page so quickly. I refreshed the page, 5 seconds after this cookie was set. So it's still valid. It still gets sent back up. But now I've just been talking about this for like 5 or 10 minutes. So at this point, the cookie is definitely expired. So I'm going to refresh the page one more time, and we're going to see what our cookies look like in our dev tools. All right. 1 page refresh. Looking back at the request again. Okay, so here in the request headers, we're only sending foo equals bar. We're not sending the temporary key because that has expired. It had a max age of 5 seconds, and that was gone, a little while ago. So the browser just forgets about it, deletes that data, and never sends it back up to the server again, unless it is set again in the future. All right, any questions about that? No questions so far. Okay. Just going to show you one other little cookie option. Well, before we just see that option. So I just refreshed the page a couple times. So now I should have 2 cookies. So you might not know this. Well, yeah, if you haven't worked with cookies before, you wouldn't know this. But you can also access cookies via JavaScript. So if you use document.cookie, that'll tell you there everything that the browser has saved. There I refreshed the page, and now it's telling me temporary key also is there. Okay, so it looks like document.cookie also takes into account the expiration for the cookies. So this cookie was removed from JavaScript like while the page was active because of a 5-second expiration. It's interesting. I thought I would have had to reload the page for that cookie to expire. So that's interesting to me. So yeah, sometimes this will be useful to have JavaScript access your cookie value so it can know things about your user's data, about their session. But most commonly, you don't want this. Because remember, the great thing about cookies is that they're stored and sent automatically by your browser. So typically, you shouldn't need to manage them with JavaScript. Just making them accessible to JavaScript is another potential security vulnerability you can have. Somebody might find a tricky way to run code on your website, and they'll access your user's cookies and then do something malicious with it. So the other cookie option is HTTP only, which means that this cookie is accessible from the HTTP protocol only, which means it is not accessible from JavaScript. So if we go back to my views, I'm going to add another cookie. Top secret. So this one should be inaccessible to JavaScript. So instead of a max age, say HTTP only. So if I look at the network tab, we can see that the server is telling me to set this cookie top equals secret, also setting the temporary cookie and foo equals bar. And then in the request headers, my browser is sending all those back. So as far as the network tab is telling me, it looks like this code is working correctly. I'm setting all these cookies. But when I try to access them from JavaScript, the temporary cookie has expired, and the HTTP cookie is just never viewable from JavaScript like that. So that's one important cookie option for just securing your application. And also just so that you can be aware for your own debugging purposes, some cookies will be visible in JavaScript, some of them will not be. That's, depending on the security or flexibility you need from that cookie. And then one other option that I just want to show you real quick, but can't really demonstrate very easily, is secure. So secure means that the cookie is only transmitted over HTTPS connections. But if a user connects to your website over HTTP, then it won't send the cookie. So this is like to make your website a little bit more secure. If the user is on HTTP connection, then it's more likely that the requests can get hijacked by someone who is pretending to be your website. So if you're sending those cookies, it's more likely that they'll get intercepted by someone who's not the intended recipient. So we can set secure equals true to make sure that the user has to connect over HTTPS in order to start a session. So if they connect over HTTP instead, we probably just send them an error message saying that you have to use HTTPS in order to start a session. Okay, so that's what cookies look like in the browser. Let's see from Django's perspective, what do these cookies look like? So I'm just gonna do some printing in the index here. So from the server, I can just access request.cookies. This is a dictionary that has all the cookies neatly parsed. So we saw before that the cookies are actually just a string that the client sends, but Django knows what that format is, and so it's going to turn it into a dictionary and make it easy for us to work with. I'm looking for the cookie with the key foo. Clear that screen there. Go to the home page. look at my terminal. All right, so here is the entire dictionary of the cookies. So it's just the same data we send up, but parsed into a dictionary in Python. Foo is bar, top is secret. If I want to get a specific cookie value, we just use the regular get method. All dictionaries in Python have this. And that tells me bar. That's what I was expecting. Cool. So yeah, that is in a nutshell how cookies work. That's like mechanically what they do. So the next step from here is we're going to talk about how would we actually use cookies to create a session, which is not a specific technology, but it's a user experience. So what are we going to actually do with these cookies? How do we use them? How do we build off of what we've learned? But what questions do we have just about the basic mechanics of cookies before we start, building an application with this? It's important that we understand this default automatic behavior before we go forward. So what questions do we have? Andrew?
I have one, Raphael. For the cookies that aren't hidden from JavaScript, can people write code in their JavaScript to automatically like put their own cookies in if they know what cookies your site is looking for?
I mean, you can manually from the client just set any headers you want. So you could manually just like set a header, just set a manual cookie header and then type in the cookie value. But if the original user's cookie that you're trying to hack, if that is set as HTTP only, then I don't know how you would get the actual value for like their session ID. So it's one thing to know like the format of like the cookies that they store. And so you could potentially try to guess, but I don't know how you would successfully guess the user's session ID number. And like I've definitely seen people do stuff like that. There was an instructor I used to work with who would do a demo where he would like have someone log in to like a crappy little web app that they made, and then copy and paste him their session ID number from the cookie. And then he would manually send that cookie up on his machine and it would log him in as their account just because he's like changing these header values. So it really is just that simple of like guessing the session ID. I just don't know how you would guess it. If it's hidden from JavaScript, like, you shouldn't be able to get it in any easy way. It's definitely good that you're thinking about these kinds of security concerns. Does that help?
Yeah.
Cool. Any other questions? I'm kind of expecting that this is new for most of us, and I'd be a little bit surprised if everyone just understands this the first time I explain it, but I guess we can continue. Oh, Jen?
So what exactly are the string values you put in the arguments for like response dot set cookie inside the parentheses? Like, what is that? What are you like putting there? Or what, I guess what I'm asking, what's the reason the strings are there?
So this is just arbitrary data that I'm sending to the client and asking them to store. So the first one is the key, second one is the value. So like to convert this into a more like Python kind of syntax, it would be if I told the client to say cookie equals something like that.
Oh, okay.
Basically just asking the client to create a dictionary. Except the dictionary is stored in strings because that's how cookies work.
Gotcha.
Jesse?
Yeah, I I think you're gonna probably get into it in the session piece, but I'm still trying to wrap my head around exactly what are the cookies doing. It's the functionality piece of it. I know that they're important. Is it a caching thing or just from a fundamental level? I'm just trying to understand it.
I mean, I guess caching is a related concept, I suppose. Like the cookies are cached on the client. The browser is saving that data. But I would say right now, the cookies aren't really doing anything. We're just storing data. So it's, I mean, like kind of like what I was saying back here, like, what does this line of code do on line 19? Like I'm just storing a dictionary and a value in a variable. It doesn't do anything. I'm just storing data. But with cookies, we're not storing that data on the server. We're telling the client to store the data for us and then remind us what that data was every time they send another request. So we haven't really done anything productive or useful. I'm just showing how we can get the client to store data for us.
Okay.
Cool. So if you've used the internet before, you might know that often when you interact with a website, you might expect that your actions and preferences are remembered by that website. So for example, if you are on a news website and there's a video that auto plays on an article, you might find the audio annoying. So you mute the audio as soon as it plays. And then you might hope that the website remembers your preference. And then if you go to another article on that same website that also has auto playing audio, you would hope that your preference is remembered and then that video is muted when the page loads. You know, a more respectful and considerate and intelligently designed news site might do this for you. Now, you didn't have to log in, you just muted one video and you're kind of hoping it remembers that and automatically mutes the others for you. Similarly, you might have been to an e-commerce website that lets you add items to your cart without even logging in. You know, you're going to go from page to page to page. You haven't signed into this website, but somehow it still remembers who you are. And even though, you don't authenticate and the page has to reload multiple times. So this user experience where it remembers you between page loads, where it kind of feels like you've entered a building and you're just walking around through multiple rooms in the same space. This is called a session. So it's important to note that sessions are distinct from logins. So typically the way we implement logging into a website is with sessions. So those things usually go together. But you should be aware that many sites will create a session for you as soon as you visit the first time, before you've ever logged in. So many websites will create sessions without logins. You can also do the reverse, have logins without sessions, but this is not super useful. So imagine for the front end of a website, so to create a pretty bad user experience, since you would have to log in for every request that you make. That would be like having logins without sessions. Although for an API, this is actually how it works, since you generally have to send your API key for every request that you make with that API. So that's basically like logging in without a session. You have to log in again for every request that you make. Okay, so the next thing that I want to do is store some data about our user. And as I showed, we can do this in the cookies themselves, just store any arbitrary key value pair. But unfortunately, cookies have a maximum size that's actually pretty small. So we can't store like tons of data on the user's cookie. More commonly, we'll just put an ID number on the cookie that refers to a user ID or a user session object, just some ID that connects it to something else, something in memory or in the database, so we can fetch the rest of their information. So I'm going to make a new route. Probably the most basic way that I can demonstrate sessions for a user would be with a counter. So we're going to make just a simple view counter. It's going to count, it's going to track how many times you visited this particular page, but it should be individualized to each user that visits it. So I'm going to create this view function. So in order to store the data for the user sessions, I'm going to create sessions object. So we're going to store all the data. Print that out just for debugging. So just a little pseudocode here. I'm going to first need to check if the user has an existing session. But I haven't created any code to start sessions yet, so I'm going to have to do that first. I just want to remember that logically I would do that after checking if they already have one. So we're going to say if session at some point, I'm going to assign session to a variable. If it doesn't exist, I'm going to create a random number for their session ID. From, I think that's 100,000 to just short of 1 million, or is that 1 million to 10 million? I don't know, a lot of zeros. So this is not super sophisticated, but I'm just going to generate a random number in this range, turn it into a string. That's going to be their session ID. And then I'm going to create a session object for them. So using their session ID number as a key in the sessions object, I'll add that key and then create an object for them. It's going to have count. This is 1, just how many times they visited the page, because this is a request. So this is going to be the first time they visited the page. And then start time. So I need date time. We want to know just how long you've been persistently refreshing the page for. So you have some sense of accomplishment. You've been refreshing this page for 5 hours or whatever. Okay. So that's if they don't have a session. If they do have a session, it's going to be simpler. So if they already have an existing session, we just look it up using their session ID number, which still haven't figured out how we're going to get that, but we're going to get there in just a moment. Then we access the count property on their session and just increment it by 1. And then afterwards, regardless of whether they had a session or not, we're going to render a page. Going to have to make this page in just a second. It doesn't exist right now. Okay, and then I pass their session in. And then we set a cookie. I'll return the response, can't forget that. All right, so remember when you render a template, you can add this context object. We would usually just create an object called data and then pass that in. Here, the session object is going to have all of the context for this request. So I'm just passing the user's specific session right in. But now I can see how this data is persisting in the client because I'm going to be setting this set cookie header with the session ID. So now I'm going to go back up to the top here and look for this cookie in order to see if they have a session. Okay, so now let's take a look at the completed code here. We go to our increment session page or increment count. And so first thing we do is we have to check if they have a session active currently. We're going to look in their cookies for session ID number, and then look in our sessions dictionary to see if we already have an object that matches that session ID number. Because remember, there could be situations where the client thinks they have a session and they send up a session ID number, but the server doesn't think they have a session. It doesn't actually exist in our object here. So there's 2 steps here. We got to get the session ID number from the client and then confirm that that actually exists in our sessions in the dictionary here. And so again, for the first request, they don't have a session. We will create an ID number for them, stick it into the sessions dictionary. And then if they don't have, or if they did have an active session already, then that's much simpler. We just have to increment the count, leave the start time the same. And then we render the template where we should be able to view that data from their session and make sure to set the cookie so that it maintains their session as long as they keep loading this page. All right, so I think we're about due for a break. When we come back, I'm going to actually build this template, and then we're going to run the code, watch the counter increment. But before we take a break and then dive back into this, does anybody have any questions about what we've seen so far? Two hands up.
Yeah. I have one question. I'm looking at the session ID number. So if we're getting that number, but it's not part of the session because the server's not getting it, it will pass over or go into the if not session area, even though they found one. I'm just trying to understand the purpose of the first
Right.
if you do get it, but it's not
So-
in the server.
Yeah, so if they do have a session ID number, then great, session ID number will be like, 5 million or whatever. But then when we do sessions.get with session ID number, if that session with that ID doesn't exist, then this is going to return none. Sessions.get will return none if the key doesn't exist in the dictionary you're searching. So then with a value of none, we can say if not session, and then that'll be true. So we'll go into this block if there was no session found. But if we did successfully get the session ID number, and then with the session ID number, we successfully got the session over here, then we'll be able to go into this else block. Does that help?
Yeah, I think I just connected them. Thank you.
Who else has a question?
My question is about the render thing at the bottom. So I don't think I've seen it before where we don't return the render. So when we're just doing the render and we're making it equal to response, it doesn't like refresh the page, right? It just gives us like this page on the side where we, in the next line on 41, we set like an attribute on that page, and it only refreshes the page once we return it, right?
I wouldn't say refresh the page, because the page is already refreshed before this code starts running. Like when I hit Command R here, my page blanks out immediately to send the request.
Mhm.
So it's already refreshed at that point. But I would say the server does not send a response until you return a value. When on line 40, when I just say response equals render request, the server is computing what the response should look like. It's generating the HTML that it can send to the client. So, it's replacing all of your Django template tags with the variable data.
Mhm.
But it's not actually sending anything to the client until you return. So if I just take out this return statement here, that's going to throw an error. It's going to say that it's supposed to return an HTTP response, and instead it's returning none. It's probably an error you've seen before. But yeah, up until this point, you've never had any reason to assign it to a variable because you didn't care about any of the properties on it. You just rendered it and returned it as is. This is the first time in our curriculum that we care about the properties on the response. And so we have to assign it to a variable just so we can access this set cookie method, and then we return it. Sound good?
Yep, that makes sense. Thank you.
Was there a third hand up?
Yeah, you answered it with that last part.
Cool. All right, so it's 10:15. Let's take a 15-minute break, come back at 10:30, and I'm gonna finish coding this up. We're gonna watch some numbers go up. Hello, welcome back, everybody. So like I said, we're gonna finish building out this view here. I'm gonna actually make this count.html template. Let's see, I want this to be at /count. So it's a 404. That's what I'm expecting. Let's actually build this now. Okay, so we've got the URL for count, loads increment count, and in my views, we have increment count. Okay. So in theory, this should work. Oh, right. Oh my gosh. I have to actually make the template. Okay, let's do that. So we're passing in their session, had two properties on it, count and start time. So just going to render them in our template. This should show that to us. Okay, cool. So I lowered the page once, and I refreshed it again. It's telling me that I visited this page 2 times since March 21st, 3:33 p.m. It's not configured to my time zone correctly, but it is the correct time somewhere. So now you can see as I'm refreshing the page, this number counts up. Also, I believe John mentioned in the chat previously, there's another way you can view the cookies. So this might be useful if you're doing some serious debugging and you don't want to just look at the cookie strings. So in the dev tools over in the application section, looked under storage, cookies, and then for this domain, localhost 8000, it gives you this pretty kind of table that shows you more, well, the same information about your cookies, just in a more organized way. So I don't have to read HTTP only true, but I get this little checkbox in a column. It's just kind of a more organized way to see the same information. So you might prefer that view. But anyways, looks like my session is working. It's counting up every time. And of course that happens because I have this session ID number cookie with the value, that 6-digit number. Yeah, it doesn't have any other properties set on it. So if I just check document.cookie, I can see it right there, my session ID number. Okay, so this is, well, actually, let me, okay, so I just want to demonstrate real quick that you can have separate sessions. So here I'm not incognito. This is my regular browser. And it's counting up, for whatever. When I go to my incognito window now, you can notice a little sketchy man with the glasses and the hat over here. I'm incognito. Now it has a separate count because your incognito window uses a separate set of cookies from your regular browsing session. So I can effectively have 2 sessions going at the same time, just so I can confirm that it's actually like different for different users. All right, so this is a pretty simple implementation of sessions. And I hope that it's enough to just give you an idea of how it works, like what the server actually does to create sessions. It's more or less like this. You look up a session ID from the database, or look up a session ID from the cookie, get that information out of a dictionary or from the database, so you can figure out more information you stored about the user. There's a problem though with what I've done in that this only works for a single route. All this cookie management code I've put right here under increment count. And ideally, the whole point of sessions is that it tracks this data across multiple visits, across multiple pages. Now, I could just copy and paste this code, that checks for the session ID number, checks if you have a session, does one thing. If you don't have a session, does this other thing, this manual like setting of the cookies and everything. Like I can do this on every route and then I'll have consistent sessions, but that wouldn't be very dry. So I want some way to apply this logic to all of my routes without repeating any code. So the way we do that in a web server is with something called middleware, which can mean different things in different contexts. But when we're talking about a web server, middleware is a function that runs for all requests, or at least all requests in some group of requests, and then can modify them before allowing other middleware or the route handler to actually return a response. So middleware can modify the request, but it doesn't actually return a response. So when a user requests a certain URL, it isn't really just one function that handles that request, but it's a chain of functions. You have all of your middleware functions that run, and then the actual route handler in your views runs last. So for the most part, we don't have to really think about the middleware. It's just kind of configured by Django. And we can actually write our own custom middleware, but today we're not going to have to do that because Django actually comes built in with middleware for defining sessions. So that's what we're going to use momentarily now. I'm going to show you how to use this built-in middleware. It's already included in Django. It is already installed in your project. I didn't even add this line of code, just doing Django start project, Python-m Django start project. Just the default scaffold already has the session middleware put in place. So all I have to do is use it basically. One difference though between Django's sessions and their session middleware and what I just did is Django is going to store the session data in the database. So that means I have to actually run the migrations in order to set up the database so that Django can store sessions. So let me see what database I've got. Okay, so this is using SQLite. I don't think I want to do that. I'm going to use Postgres for this. All right, we're going to use Postgres. It's complaining because I don't have PsychoPG2, so let's get that real quick. Cool. So it looks like we got PsychoPG2. Run make migrations. Pretty sure this will do nothing because I haven't actually changed any Django models. We're just using Django's built-in session and authentication models. But I do have to run the migrations. Oh, because I've already used this database before. I'm going to create a new database real quick. Creating a new database that has not been used before for a demo. Okay, so I've run the migrations on this fresh database. And then one of these off migrations here is required for actually setting up the sessions. Oh, actually it's this one, sessions 0001 initial. So that is required for setting up sessions. So that is why I ran the migrations. Okay, so now what I'm going to do is rewrite this increment count view so that it actually uses the default built-in Django sessions instead of this kind of funky improvised sessions that I just created here. All right, so let's forget about all that. Just going to comment it out so you can review it later if you want. Okay, so first of all, just like before, we're going to check if the user has an existing session. But the way we do it now is going to be much simpler. There's a property on the request object called session. So what this will do is if the user already has an active session, the Django middleware will attach that session dictionary to the request object, and then you can access it just through request.session. And then I'm accessing it like a dictionary normally. And just for formatting, we're going to turn that date to a string. Okay, so this should do exactly the same thing as our previous view function that we have up here, except now this is using the built-in Django sessions. So you'll note that I don't have to check for the session ID. I don't have to check their cookies. Django has automatically put their session, if it exists, onto request.sessions. I just have to check if it exists. If it does not exist, I don't have to manually start a session. I just add data onto the session object. So you never have to tell Django when to start a session. But if you attach anything to the session object and they don't have an active session, Django will automatically create a session for them for you. So that's very convenient. You don't have to ever ask yourself, do they have a session? Do I have to create this object or use the one that already exists? You just attach data to it. And if it needs to be created, then Django creates it for you and manages the cookies for you. You know, I don't have to set any cookies down at the bottom. It's very convenient. So let me just start my server again. And so now my session has restarted at 1 because I'm using the Django sessions instead of my custom sessions. But you can see that the page is still working the same way. Here I'm up to count 4 in my incognito window. If I go to the main window, now I'm back down to 1. We can count that up. Over here, you know, I'm back at 4. So I have 2 separate counts for these 2 separate sessions. One being incognito, one being cognito. I don't know what the opposite of that is. So yeah, that's just how we can implement sessions without logins in particular. So that's great. Like before a user has logged in, if you need to still track them between pages, Django sessions are very useful. see. Okay, so we're gonna go on to talk about signing up and then logging in. Which is also gonna have to involve password hashing a little bit. But before we move on, does anyone have any questions just about Django Sessions? Andrew?
So we don't have to set session ID in this case, but I'm guessing there's like a Django automatically set session ID
Oh
somewhere.
yeah, for sure. Let's look at that. Yeah, okay, so here, set cookie, session ID. This is from Django. So you'll notice this is not just a random 6-digit number, but this looks more like a random alphanumeric string. So this is actually like a proper session ID that Django set. But my browser is still sending the session ID number from my custom sessions because that cookie hasn't expired yet. But yeah, this is the one that Django is actually telling us to set. Sound good?
Yes, and we can also set a timeout for this one too, right?
Yeah, that's gotta be configurable. So yeah, this is built into Django Sessions. You can set an expiration date. Yeah, so all of the normal cookie management features and techniques that I just told you about, that should also be accessible through Django somehow. They don't like put it right in front of your face, because in theory, you should be able to work with sessions without thinking about cookies every minute, but it is accessible to you if you need to go to a lower level and change things. Are there any other questions? No more questions. Okay.
Sorry, I had another one real quick.
Mhm.
Middleware, what is it really? Is it like a dictionary Django is keeping in the background that's like tracking us entirely? It's not like another like hidden page template or something, right?
I think of middleware as being kind of like a pipeline of functions that like pass the request from one function to the next until they ultimately get at a route handler. So I guess let me put it this way. You remember before when we worked with some route handlers that were like ambiguous, like you could write one route handler that would match multiple requests. Like we were using the dynamic URLs that had variables in them and stuff. Does that ring a bell?
Yes.
So imagine if you have a route that can match multiple requests or every request, but instead of sending a response, instead of rendering a response, it says, okay, now the next route handler can look at the same request. So you have like one of these functions that looks at the request, and maybe it sets properties on the session or sets cookies or other things. But instead of sending a response to the client and then ending that HTTP request cycle, you let the next view handler also process the request. So that's kind of how middleware works. It's like you've got a series of these view handlers, except instead of sending a response to the client, they pass the request to the next middleware. So like, if you look in your settings, all these middleware, these are 7 different functions that run in this order for every request that comes through the server. And so some of them are going to be, like the session middleware is setting and reading cookies and setting the session property. Security middleware is probably looking for certain cookies and headers and then like sending errors if it's not getting what it expects. Authentication middleware, we're going to work with this a little bit tomorrow, and that's going to automate some aspects of logging in and signing up. So I'm just going to show you like, oh, Django magic happens here. You don't have to write code for this part. And that's because the authentication middleware is going to do things for you automatically. If we had more time, I would love to show you how to like write your own middleware, because it's definitely accessible and it's a solution that you should be aware of exists. For some problems, that's the right solution. But incidentally, for all the problems that we're going to have in this course, we either won't need middleware or Django has something built in that will handle it for us. But I do think it's an important concept to understand, even though Django provides these things for us automatically. Does that help?
Yeah, it definitely helps my understanding of what is happening.
Cool. Any other questions? Question. Okay. So we're going to make a registration page really quick. But before that, I want to talk about some vulnerabilities that can exist potentially with cookies. So it's very convenient for the most part how cookies work. You know, when I've showed you how the browser automatically stores them and then automatically sends them back up to the server appropriately. It's very convenient for most use cases. We don't have to write any code on the client side to handle authentication. The browser just does it automatically by default. But unfortunately, this creates some opportunities for hackers to exploit our application. So I don't want to dive like fully into the details of this because this isn't a security boot camp. But long story short is if a hacker tricks someone into clicking on a link to a website that they have cookies for, their cookies will be automatically sent to that website as part of that click. So imagine like if someone emails you a link to like Facebook or something, but it's not just the homepage, facebook.com, it's some very specific URL like facebook.com/reset password, and it like resets their password all in one request. Then when you click on that link, it's going to send that request to Facebook from your browser with your cookies. So a clever hacker can exploit your actively logged in session and trick you into performing requests against the server using your own identity, not their identity. So this is called, CSRF, or cross-site request forgery. CSRF. So honestly, in my opinion, this isn't a super dire vulnerability. There are much worse ones that you should be more aware of. There are like security organizations that'll publish their top 10 list of vulnerabilities for 2022, 2021. And this has fallen off the top 10 list as something you need to be particularly concerned about. But for whatever reason, Django thinks that this is a very important security vulnerability. And so in many cases, Django forces you to protect against it. There are lots of requests that Django just won't let you send unless you have like satisfied it and protected against this vulnerability. I think you saw that before when we were doing the more traditional form submission, but I'm going to do some AJAX form submission today. So that way that we handle CSRF is going to be a little bit different going forward. Except I'm not actually going to handle it today. I'm just going to disable Django's CSRF protection just so we can focus on the concept of cookies and sessions. But in a future lecture, probably next week or something, we're going to learn how to properly satisfy Django's CSRF requirement from an AJAX request. So you might have seen this before, this CSRF token that you have to include. When we were working with traditional forms, it was pretty easy just to sneak it in there. We didn't have to think too hard about it. When we get to AJAX, there's going to be a little bit more work we have to do to get around this to satisfy Django. So we're just not going to deal with that today. Come back to that in a few days. But this is what that's for. It's just an extra bit of data that is manually added to the request just to prove that we weren't just automatically including all of our cookies and that we didn't get tricked into sending this request, but it's a legitimate request that came from our actual website. So Django has a built-in decorator that we can add to certain routes, CSRF exempt, that will just disable the CSRF protection on that particular route. I'm going to be using that a little bit today before I show you how to properly handle it in a week or so. So I just don't worry too hard about that. I just didn't want you to get distracted by it. Okay, so next up, I want to try and register a user. We're going to need to actually have a user model, though, in order to do this. So I open up my models file inside of the blog. I'm just going to create a app user model. Note that user, this is like a predefined class in Django already. Don't name your class user because that already exists and you don't want to overwrite the built-in user model. Bad things happen if you do that. So I'm going to call this app user. Extends model.model. We're going to use their username as their actual login. Sometimes it's email, but we're going to use username here, so we're making that unique. Passwords in another char field is not unique. Max length of 99. Going to make a sign up route. Take the request. Don't want to deal with CSRF protections here. All right, so Django has this built-in decorator in Django views decorators, CSRF exempt. I apply that to my route here, and so now Django is not going to throw security errors because I'm not satisfying this requirement. So the next thing I'll have to do is I'm gonna have to make a sign up page. We're gonna use some JavaScript to just send a login request to this page. But the problem is that I can't just store the user's password in the database. When they register, they're gonna send a username and password in the post request. And kind of the naive approach would just be save them both in the database. And then when they log in again, check if their password matches what you have in the database. But that's super dangerous and we should never do that. It's really important just generally that you never store plain text passwords anywhere on your server. It's just a huge liability because you don't need them to operate your application. And if your database gets compromised, a hacker is able to download all your database tables, then that could be a really big problem for you if they're able to access all of your users' plain text passwords, and then nobody has any confidence in your application or your company anymore, and you lose all your users. Although actually sometimes the reputational damage is not really all that bad. There was an incident, I want to say this was 2 years ago, maybe less even, where it was revealed that Facebook was storing plain text passwords in their logs. And people got kind of upset about that for a day and a half and then forgot about it, which I think is pretty damning. But just goes to show you that this is a mistake that even big companies make sometimes. So we need to hash our passwords before we store them in the database. Can anyone tell me what a hash is? What hashing means, what that does?
It's like a one-way cryptographic function.
Yeah. So the important part there is that it's one way. Whenever you hash a value, it turns it into a string, and that it does so deterministically. So if you hash the same value 10 times, you should get the same output every time. But the important part is that it's one way. So when you hash a value, there's no straightforward way to reverse that into the original input. So this is different from encryption, which is a two-way operation. Anything that you encrypt can be decrypted, provided you have the keys. Okay, so let's say a user signs up for our site with the name Jeff Bezos. Password is dragons. So we don't want to actually store dragons in the database. We hash it, and that turns it into some random string of alphanumeric characters, maybe like ABC1. Okay, so just totally random string of alphanumeric characters. That's our hash. Now, so this is definitely more secure than just storing plain text passwords in our database, but there is a problem with what we're doing here. So for one thing, many experienced hackers will have already hashed a variety of common passwords. So like normally if you want to just guess passwords, it takes a while because you have to run the hash algorithm every time you guess a password. And the algorithm is not as fast as possible. That's by design, so that you can't guess a billion passwords in an hour. But some clever hackers might have a table of pre-hashed passwords. So they know what the popular hashing algorithms are. They know what common passwords are. So this user might already have the hash of dragons stored in a table. So they can just check if this hash is in their table. They don't even have to like rehash this password. This is called a rainbow table, this list of pre-computed hashes. So there's one other problem with our hashing scheme here. Let's say we get another user who signs up. This is Tim Apple. They use the password also dragons. So remember I said hashing functions are deterministic. So if you hash the same input, you get the same output every time. So if I hash dragons again, I will again get ABC123 BBQ. So now I have a problem that there are two identical hashes in my database. So if someone hacks my database, for one, this is a hash that might exist in a rainbow table, but also the hacker can see that there are two identical hashes. So if they crack one of them, they automatically cracked all of the other ones that are the same, because they can tell that it's the same password because it's the same hash. But also a hacker can assume that this is a very weak password, because like, honestly, what are the odds that two or more users for your app randomly chose the same very secure password? Odds are if multiple users in your app have the same password, it's a very common password, like dragons or princess or password or something like that. Or let me in, knock, knock, those kinds of things. Okay, so it seems that hashing is not quite sufficient to give us the security we want. So we need to add another step. We need to salt the passwords. Anyone heard of salting in reference to salted passwords, salted hashes? Anybody? Nobody?
It's some to prevent people from doing just what you were talking about, comparing the hash to a list of hashes.
Mm-hmm. So salting, we're going to add a little bit of extra randomness, some extra string that's going to be included in the hash. The purpose is to guarantee that all the hashes in our database are unique. So to take the example from before, username Jeff Bezos, salt. Make that look like a variable. And so Tim Apple gets a different salt because these are randomly generated for each user. But then what we store in the database is going to actually be something like this. So I'm using the Python f-string syntax to show you that I'm interpolating a variable here. So when we hash them, we concatenate these two values together. We take the user's password that they inputted and then just random characters that we generated and then hash those together. So that way, even though two people use dragons as their password, the salt is purely random coming from the server. So there's no way that two users are going to have the same hash. And then to remember the salt, we just store it right next to their password in the database. So that's something that I've seen trip some people up. They think the salt is supposed to be like the most secret part of this whole process. But by design, the salt is not any more of a secret than the hash itself because they're stored next to each other in the database in the same column. Okay, so the sign up flow in more plain English. So this is optional, but very commonly after a user signs up, you also log them in. People kind of expect those to happen together. It's a little awkward if you have to manually log in and type in the same credentials after you just signed up, but it's not technically part of the sign up process. Jesse, question?
Yeah, just clarify. So the password, does the password and the salt will be combined together and then turned into the hash, a new hash, instead of just the password itself going into a hash table.
Correct.
Okay. I just making sure I understood that.
Yep.
Okay.
You got it. Are any other questions? I think we're about ready to take a break, and then when we come back, I'm going to code up a simple sign up page. But do we have any questions before we break?
Real quick on the other one, the F string with the salt what's the what you put, so you have salt and you have the hash string. That's just the hash string of the salt plus the dragons, and then they put in the salt in addition to it.
Right. So it's almost like the salt gets in there twice
Okay.
because the salt is used in computing this hash. But then what we store in the database has the plain text salt also right there.
Okay. All right. Thanks.
Yep. It's a little bit of a weird flow the first time you see it, I think. Any other questions before we take a 10-minute break? No questions, going once, going twice. Okay, it's almost 11:20. let's come back at 11:30 and I'm gonna create a sign up route. All right, everybody, welcome back. So for the last part of this demo, I'm going to make some login and sign up routes. So while we were away on the break, I just made a couple quick pages. Login HTML, sign up HTML. There's almost nothing going on here, just blank HTML page with a link to a script. These scripts are empty. I'm going to have to write them in a second. Oh, let me spell request properly. Okay, and then got to set that in our URLs. So let me just see if I can go to that sign up page. Okay, so the page loads, does nothing. I'm going to use Axios to send an HTTP request from this page. I'm just going to grab that real quick. So there's a link to the Axios CDN. And then I've also got my signup.js. And here I'm going to actually send a request to my server. Okay, great. So this is going to send a post request to /signup. But now we're going to have to handle get and post requests a little bit differently. So if request.type method forget what it's called exactly. Request.method. Okay, so this route can receive both get and post requests. I'm going to say if request.method get, do that. Okay, so if they're actually sending a post request to sign up, they're not trying to access the page, the sign up page, but they're trying to actually send their credentials to sign up. So here's where we're going to actually do some password hashing. So if it's a post request, there should be a body. Let's just print just the body. See what that looks like. Just refresh that page. Just complaining that I didn't send an HTTP response yet, and I know about that. Okay, so here's what the body looks like. It looks like a dictionary, but it's actually a string. So we're going to have to parse this JSON string into an actual dictionary we can use. So that'll turn that body string into an actual dictionary we can use. So this is the password that the user actually typed in. The password dragons that we saw there. So now we need to generate the salt. I'm just going to create a quick little helper function that does this for me. Just generates a random string as the salt. All right, and then for the actual hashing, I'm going to import another library. This is built into Python. Just have to import it. Hashlib does what it sounds like. It's a built-in library for hashing. Don't worry about the specific syntax of it too much, but this is going to let us pass it any string input, and it's going to return a hash. So we're going to use the SHA-256 algorithm in this case. Passing in the salt plus the raw password, we're just concatenating them. Then in order to actually get the hash in a human readable format instead of just a list of bytes, we have to encode it and then call Hex Digest, which is part of the password hashing API. Don't worry about that too much. But let's see what it looks like. I'm just going to take a quick look at these values. Just going to send a generic response back so that server doesn't complain that it's not sending responses. We refresh the page again. So looking in our terminal, the salt is this random string, kind of like I was saying. When we combine the salt with their password and we hash them, get a bigger string like this. So this is a hash that we get with the SHA-256 algorithm. So that looks completely unrecognizable based on their input password. So that looks like a successful hash. We've masked their password. So this string here is actually fit to store in the database. So then we can just create an app user. Just import the model. All right, so here's getting a little tricky. So remember, this salted hash password is just the result of hashing salt plus the raw password. But this by itself is not what actually gets stored in the database. It's going to be first the salt, and then this random $, and then the salted hash password. So it's common convention, you put $signs in hashes to separate the different parts of it. It's a salt and a hash, so we use the $sign to keep those separate. Save them in the database. And yeah, so let's see what that does. So I'm going to refresh this page again. That did not work. I'm thinking I did not run my migrations after I created that model, so I probably have to do that. Make migrations. There we go, created the model app user. Migrate. And we ran that. Okay, cool. Let's try this one more time. Oh, I have to actually start the server. Try that. Okay, cool. So now I'm loading that sign up page. It automatically sends that sign up request because I just hard coded the request instead of putting a form in here just for speed. But it looks like that was successful. So I'm going to open up another tab here. I'm going to use pSQL to see what's in my database. My user model is called blog app user because Django automatically concatenates the app name to your tables, if we remember from the other day. And so here we have a user successfully stored in the database, Jeff Bezos. Their salt is all of this stuff up until the $sign, and then their password is everything that comes after it. So I've got a user in the database now. I've successfully registered, but the next thing I need to do is log them in. So I'm going to create a separate route for that. Although more practically, you might incorporate some of the login functionality as part of the sign-up flow. It's a little bit more advanced. Going to leave that as an exercise to the readers, viewers. So this is going to get a post request again. So we'll just check. Sorry about that. Request method is get. We will render login.html post. Then we will parse the body. So in the body, it has a username. And so first, we're just going to look up the user that they're trying to say that they are. So we have fetched the user from the database that this person logging in is claiming to be, but we have not yet verified their claim. So remember, their password in the database has two parts separated by a $sign. So we want to get those different parts. We have to split the password. $sign. And since we know how this hash was constructed, I just know that the salt is the first part of that. And then the actual hash of their password, the password plus the salt, is in the second part after the $sign. So now, in order to test if this person actually is who they say they are, we're going to rehash the password that they sent us with the salt that we got from the database. So I'm going to call this the challenge hash, because I don't know if this is the correct hash. This is what our person trying to log in is saying it is. They're challenging our authentication system. Okay, that looks right. So we grab the hash and we try to rehash that. Yeah, hold on. So we grab their salt, combine the salt from the database with the plain text password from the request. That's the challenge hash. And then ideally, that should be equivalent to their hash password. So if this is true, if these match, so if these match, the user is valid, they are who they say they are. And so yeah, if they are who they say they are, we've determined that they're valid, we'll set a cookie for their user ID so that that way, when they send subsequent requests to the server, we'll know who they are in the database and we can just look them up by this user ID. I don't think there's enough time in the morning for me to code out that part of it, but hopefully I've shown you, all the authentication bits, the new content today, and you should be able to piece this together with the database work that we did last week. Now at this point you have a user's ID, you can look them up from the database and access any of their data. You can incorporate it into the views that you render. Although probably instead of using set cookie here, you might prefer to just use Django Sessions. So that way you don't have to write redundant code checking for this cookie. So I'm going to do some similar stuff in my login HTML. These two scripts. Now login.js is going to be very similar to signup.js. Except we're going to send this request to a different URL. All right, you notice that I just signed up and it said it was successful and we see the user in the database, but it doesn't start a session for me. Yeah, I'm not sending or receiving any cookies. So those are distinct separate concepts. But now when I go to log in, I think I have to add the URL here. Yep, just uncomment that. Oh, okay. Okay, you do not log up, you log in. Gotta get my log direction correct. Okay, there. So now it looks like we have successfully logged in. We didn't get any errors there. If I look in the network tab here for this XHR request, that's the AJAX request that I just sent to my server. I logged in successfully, so it is telling me to set this cookie, user ID equals 1. And so now I've not built this yet, but you can use your imagination that maybe the next thing that I would build into this application is some logic in the other routes that checks in the user's session if they have a user ID set. And if they do have that user ID set, you look up that user from the database and assume that that's who the session belongs to. So that is logging in and signing up in a nutshell. Tonight you have an exercise that is going to be pretty similar to what we've shown today. You're going to manually implement logins and signups using the techniques I showed you today. But kind of the one extra challenge is that you need to allow an unauthenticated session convert into an authenticated session. So maybe you've seen this flow before, where you're on a website that really wants you to log in, but they don't want to force you to log in because they want the website to be easy to use. Because, you know, like typically if you go to a website and they force you to log in before you can do anything, you're probably just going to leave. Like you're not going to jump through all those hoops to figure out what the website is about. You don't have the patience for that. So a lot of websites, like even if you have to log in before you can like check out, before you can actually purchase things or whatever, they still try to make as much of the website accessible as possible before you actually have to log in. So some websites might let you add items to your cart before you're logged in, and then you don't actually have to register until you want to pay. You know, in order to add a payment method, you can't put that in the session. That has to be part of your user account, perhaps. So what these websites will do is they'll just create a session for everyone as soon as they go to the home page. But then if someone registers for the site, you check if that user, when they register, if they have an active session, and then you attach that session to their user object in the database. So they can pretend like they have been logged in the whole time. Because like it really kind of sucks if, you know, you go to a website, you add items to your cart, and then you register, and then your cart gets deleted. Like that is not a user flow that anybody wants to experience. Ideally, you go to the website unauthenticated, add stuff to your cart, you log in, and you still have the same cart, only now it's associated with your user account. So you could like log in on a different computer and then access the same cart. So we're basically just practicing that kind of smooth authentication flow where you convert an unauthenticated session into an authenticated session. Does that make sense to people? Do we understand what we're being asked to do here? I'm gonna interpret your silence as understanding, so that's great. Do people have any other questions about any of the content today? Any of the code or the concepts? A lot of big ideas that we covered. Jesse?
Yeah, so everything that we just covered today, will we be able to utilize that with the with everything on for today's session to be able to work on the shopping sessions here
Yeah.
with ease, or do we need to do some digging?
I want to say like 95, 98% of everything you need for tonight should be included in today's lecture. Certainly, if you feel like you're missing something, it's not going to be in the Django documentation, because this is not like the Django way to do things. This is just for our learning purposes. We're going to do this tonight. And then tomorrow, I'm going to show you the Django way of doing these things. But yeah, everything that you need should be in the lecture from today.
All right, thank you.
Any other questions?
Yeah, for the JavaScript that you were writing to post the username and password, was that just kind of in lieu of writing a form to send that, just because like as a quicker way to, I guess I'm wondering, why did you hard code a username and password into this web page?
Because it's almost noon now and I didn't want the demo to be any longer. So in a more proper application, instead of me just hard coding these credentials, there would be a form. I think.
Yeah, so I was just asking, so you just kind of did it as a stand-in, so you need to pull all the info from like an actual form on the web page, right?
Right. And then, you know, yeah, instead of hard coding these values, they would come from the web page somehow. I would have to pluck them out of an input. So, you know, I could just use like document get element by ID. Very soon in React, we'll be learning much more organized ways to get the data out of our forms. But yeah, you can just kind of do it a slightly less elegant way for tonight. Just use document get element by ID to get the values out of form inputs. Because yeah, ideally in a real application, you should be able to sign in as different users, not just Jeff Bezos. So yeah, that's an exercise left to the readers for tonight. I saw another hand go up.
Yeah, just I guess, I don't know if maybe I'm missing something. So we should be using Axios instead of like Django forms or whatever for the assignment tonight. Or is that just like your preference on how you did it this time?
You know, I'm going to say you can actually do either. I haven't tried doing this demo with Axios form or with Django forms, so I don't know exactly how you might have to change it. It might end up being very similar. I chose to use Axios just to kind of like get us ready for what's to come, because pretty soon we're going to be integrating React with Django. And so at that point, we're going to be using Axios and just Ajax in general for all of our requests, and going to use traditional page submissions very rarely, if ever. So just to kind of get us accustomed to what's to come, I thought this would be a more useful style, but I'm not going to insist on that for tonight's homework. Axios is not what I'm intending to challenge you on. I'm just want to make sure you understand this login flow. So if you can get the data to flow any way that you know, that's fine.
Thank you.
Any other questions?
Yeah, one more question. So you stored that the user had logged in just with a cookie, so like with as their user ID. Is that pretty common to validate that someone has logged in is just setting a cookie with their user ID, or is that kind of just again, like an easy way of doing it right now, and there's other ways of doing it?
It's a little lazy. I think this is maybe not the most secure option, honestly. What would be better was to do something more similar to what I did before, is to just have a sessions like object dictionary that stores their session ID. And then their session would include other information about them, including the user ID. So it's kind of the same thing, except instead of just having the user ID in their session, which lets me look up the user, they have a session ID in the session, which lets me look up the user ID, which lets me look up the user. So it's kind of the same flow, but just an extra step. And I just didn't want to do that extra step. I thought I would put everything more in the same place, so it'd be easier to read. But again, when we get to the Django way of doing these things, you're not going to have to worry about handling that yourself manually. Django's going to take care of those sensitive details for you. Good question, though. Any other questions? Going once, going twice. All right. So that concludes today's lecture. But actually, right before we go, there's one other thing I want to show you for like 2 minutes, just because I think this is cool. If you're interested in password security in general, you might be interested in hearing about rockyou.com, which is a website that I'm pretty sure does not exist anymore, but in like the mid 2000s or whatever, they were a fairly popular multiplayer gaming website. And famously, they got hacked and were storing all of their passwords in plain text. And so since this attack, the passwords of RockYou users was leaked. And this is a pretty common like word list for people studying passwords. Like if you want to know something is a common password, it should appear nowhere on the RockYou word list. So if you're curious, you can just download it. It's hosted a bunch of places. I just found it here on GitHub. It is a 33 megabyte text file. So this is a lot of text in one file. Come on. So yeah, this is 33 megabytes of just text with all of the most common passwords in order. So 1, 2, 3, 4, 5, 6 is the very most common password on that site, right before 1, 2, 3, 4, 5. Bunch of like password, I love you, lots of people's first names. Dragon right up here in the top 50, top 100 or something. I don't know why I think this is funny, that this is a common password. I actually bought a domain a few years back. The password is dragons.com, just because I think this is a hilarious joke for some reason. Nobody else thinks this is funny but me. But anyway, these are all common passwords. If your password is anywhere in this list, you should change it immediately. And if you just want to practice like cracking passwords and cryptography stuff in general, this is a cool thing to know about.